In this session, we will learn about Retrieval Augmented Generation, which is RAG. Now, RAG has many utilities. The one utilities we'll be looking at in this case is question answer model. Now, first of all, let's look into the flowchart of what we're going to do, and then we will apply that into coding. So first of all, I will upload a PDF. So my PDF here is all about paracetamol. Okay, so let's upload a PDF. Once we have uploaded the PDF, the very next thing that we're going to do, we're going to split this PDF into chunks. Okay, now this is how it will look like. I mean, with a lot of literature, but yeah, it will be in a splitted formation. Now we will use Langchain to do this. Now, if you want to know about Langchain, I will have a further video on it. But let's take it as a package where we'll download it and then we'll go about doing our tasks. Okay. Splitted this PDF into text. The very next step would be putting this text into embedding model. So in our case, we would be using open source HuggingFace model. Okay, let's put this text into the embedding model, and the embedding model will give a dense vector as an output. How does this dense vector look like? It is nothing but a numerical representation which captures semantic meaning. Now, to store this, we will have a special database, and this database is nothing but a FAISS database. Now, let's understand why we would be using, not a traditional database like, MySQL or Oracle, and why only FAISS, which is from Facebook, first of all. Now, it is designed to scale efficiently with millions and billions of data. The reason why I say so, the numeric data carries semantic meanings, and it has got sequence as I has 300, 512, or 780. This could be a sequence, and it lives in a very high dimension. When I talk about a dimension, these vectors live in 100+ dimension. Okay. Now, when you do a computation such as Euclidean distance, cosine similarity, computationally it becomes very expensive, and which our traditional databases fails to do it. So it's very efficient and efficient in search and retrieval while using this type of database. Okay. Now let's ingest this dense vector into our FAISS database. Okay. Once we've done this ingestion to this database, the very next step is user comes into the picture. This user could be you and I, whoever is coding it. A very next step that we're going to do is we're going to give a question to this database. Okay. Now, what would be our question here? Question as basic as, since I told you this PDF is all about a paracetamol, you could ask, what is paracetamol? So to this, it will give you a context. Okay. It will reply a context. Now this context will be, it is going to find all the relevant information related to what is paracetamol that you've asked for paracetamol. Now you have the question and you have the context. We'll pass these two things to our LLM model. Okay. And this LLM model is going to find us an accurate answer. Okay. Now, this is what LLM is known for in this case in question answer model, that it integrates your retrieved documents or passages with the LLM to give you accurate context-aware responses. Okay. Now, since we know this, now this is the entire flowchart. Okay. It looks very simple. If you can keep that in your mind, this entire flowchart, which is just few steps, we'll apply this into the coding. Okay. Let's jump into coding now. What we will do here is we will import a package, and that package is nothing but, which I said, we will install Langchain. Okay. So we'll do quick pip install minus q is nothing but quiet. Okay. It is not going to give a lot of outputs. Okay. Yeah. Langchain community. Okay. That's the package we have. So once you have installed this, the very next step that we'll do is we'll upload the PDF. So while it's taking some time because I have not started the cluster. So just to remind you that I'm using Google Colab, and it is not a pro version. Okay. I'm just using the CPU version only. We'll look into this error message later, but let's quickly upload the data. Okay. Oh, sorry. I mean, before I upload the data, I just made a mistake here. Okay. Create a folder first. Okay. As data. Data. Okay. Delete it from here, and my data is now residing in which I've just created now. Okay, now let's come into the error that we've got. It's pip install. I made a spelling mistake here. It's going to be Langchain community. Okay, I'll quickly type the command from, once you have installed Langchain, you're going to use Langchain. Okay, from called document loader. Okay, that's the package that I'm going to use to uh, upload our PDF. Okay. I will also add another package, okay, that is going to split that PDF we have. So from, if you remember that we have splitted that, right, into different text. Yeah. So you will use Langchain dot Langchain CHI. Okay, CHI. I made a mistake here. To import, remember this, it's going to be recursive character text splitter. Okay, that's the name of the package. So if you do it twice or thrice, this thing, you can easily remember all these packages. Okay, the very next part, I'm going to give the path of the PDF. Since I've already downloaded the package, how quickly you can do it? You can just click on these dots, copy the path, and then you quickly paste it out here. I'm going to use this PDF loader. So it might fail for a reason I'll just tell you, but if it doesn't fail, well and good. I'm going to use loader as done yet. Once you have done so, PDF loader dot path, what you have to give is, say for example, I have split doc. That's the name that I'm giving, and now I'm going to load it. Okay, loader dot load. So let's see the look and feel. Okay, this is where I stored it. Okay, how will the doc look like once you have loaded it? Okay, your entire document should look like. I'm in the first now. So if you see the page content is what we'll be looking at every time. Okay, so page 0 we are in. So if you go down, you can see, yeah, we'll further see it. Let me just hide it out so that it becomes convenient for us to code ahead and look up and down both. Now, now I'm going to split it out. So you know already the package. Now the package that I'm going to use. Okay, so this is the package, recursive characters text splitter. Okay, the functions that I'm going to use. So let's name it as text splitter. I'm going to use the recursive. Now there are two parameters it is going to take. One is chunk size. Okay, chun. Spelling mistake. Chunk. Chunk underscore size is equal to, I'm just putting it 100 given the PDF that we have, and if you have a very high documents you can give it 1000, but I'm keeping it 100. Okay, now I'm going to give chunk overlap. If you keep an overlap between all the sequence so that it doesn't miss out on the context. Okay, yeah, so I'm keeping overlap of 20%. If you see, I'm taking 100 and I'm putting 20 as an overlap. That means 20% of the overlap I'm keeping between the sequences. Now once you have done so, I've instantiated it. Okay, next I'll have to let's call it out as text, and I'm going to use this text data. Okay. So I'm going to say split document by this split doc. All splitted here. Okay. Now let's see how does it look at now. Now see, it is all splitted here. If you remember the moment PDF was uploaded, I showed you right in a list format text. It's the same thing that you get. Now page content is where you're going to get all of this. And if you look into the page, you have page 1, 2, 3, starts with 0, and we have just 5 pages. So you understand why I took a chunk size of 100 and then overlap of 20. Okay. So again, let me just hide out the output. Okay. Remember from the flow chart, what I did was embedding. Okay, so to start with embedding, first of all, you need to install sentence transformer. Okay, because that's from here only I'm going to use that model. We'll pip install, which is nothing but white. You can just go ahead without Q. I like it because or else it is going to give a lot of output. Okay, I need sentence transformer. I've installed it, and now let's do one thing. And now, if you remember Langchain, because I said right in the beginning, we'll take help of Langchain to solve our problems. Now we have to do embeddings. So from transformer, we're going to take the model, but from HuggingFace, we're going to take the this thing. We're going to take the embedding. Okay. So now from Langchain, okay. That, yeah. Let's name it as model path. Okay. And our model in this case would be SENTENS going to use it all under mugged it up. I already have a reference here. I'm just following that. Okay. If I have made any mistake, it is going to throw me an error. So I'm just checking it once. Okay. Now this will take a couple of parameters. Okay. There is not a couple of parameters, just two parameters. One is model quarks. Okay. It is quarks. I'm just saying that my device is going to be a CPU, which is, I mean, if you're not using Google Pro, then you must definitely use it. Okay. You must call it out DEVIC. And if you're using CPU, you can GPU, you can mention it. Do it. Another thing that I'm doing is I'll call encode quarks. Now, what encode quarks will do here, it is going to ask whether are you doing normalization of the embedding or not. So I'm normalizing. I'll put normalizing equals to false because I don't need to normalize it. Okay. Have I made a mistake here? Yeah. See. Let me instantiate. Okay. What have I done? Okay. I'll instantiate this model. Okay. In the next line of code where I'm going to name it as embeddings. So far, I've just called on the parameters and the package. Okay. Now I'll call it as embeddings. Space embeddings. Okay. And then model name here is okay, which I named it as a model path. I named it as model quarks only. For simplification, you can do as you wish, but yeah, I've written right. So in code, it will be equals to let's do it. Now from here, what I'll do is I'll instantiate it. Okay, and all the parameters properly. Okay. With the name. So I said if you have any problem with the model name, it will give you this problem. So yeah, let me quickly check if I made a spelling mistake somewhere. It's I've rectified the model name. Hopefully it will work now. Let's see. We have, it's completed. Now, if you remember in the step, once we have done with the embeddings, we are supposed to put this dense vector into FAISS database, right? Into a database. So let's pip install that database quickly. Pip install CPU. Okay, that's the installation you need to do. Now again from Langchain. Yep, I'm just calling it out as DB database and FAISS. That's the import that we've done from documents from document. Final thing that we had in the splitted chunk was text, if you remember. So I'm going to use that. Embeddings. Embedding is what here, right? This is the model that I've instantiated for doing the embeddings. So I have the text, I have the embeddings, and now I'm pushing it into a DB. call it as vector stores. Okay. Understood the flow that we have done the database, and the very next step, once pushing this text embeddings into the database, I showed that user comes into the picture where we ask question to the database, what is paracetamol, and we retrieve context from it, right? So we're going to do these steps of user little later, but before that, what I'll do is I'll instantiate the LLM model here. Okay. I could have skipped this step for later, but let me do this so that our flow becomes even easier. Okay. So what I'm trying to do now here is I'm just preparing the LLM model. Now for this LLM model, I have to pip install transformer, as you must have guessed it already. I pip installed -q. And from transformer, then I'm going to install a couple of packages. Okay. transformer import to perform auto tokenizer. Okay. Converting those text. Okay. Do that, and I'm going to do auto model for question. Okay. Auto, model I have, not a document question answering, auto model for one thing that I need is a pipeline, because we'll create a pipeline. Yeah, EE suffices us for running LLM model. Okay, here. Okay, the model that we're going to use is part 2. That's the model that I'm going to use. Now, this model is very specific for question answering. It has got other features as well, but we're going to use this for question answering. Now, the next moment is I'm going to create a tokenizer. Now, for tokenizer, what I'll have to do is I'll have to take these functions that I've just imported it, and then I'm going to say from pre-trained. Okay, pre-trained. So just say the model name here. This is the model name, right? Model I have named it. One is padding equals to 2. I'll tell you why I'm giving padding equals to 2. Let me put the parameters first, then one by one I can explain it to you. We also give you truncation. Length of. Now, why I have defined these parameters? Model is understand. I could have just executed with that. Padding why I have given is that, see, if all this has got some sequence, okay, initially when I told you this text will have some sequence and they will be split in that sequence. I'm saying that max length will be 512. If it is beyond that, you will going to do a truncation. That's why I mentioned truncation equals to true. And if it is shorter than 512, which is very highly likely, it will be. If it is 400, it is 300. If it is just 50, rest all the spaces that you have, fill it with empty space. That's what padding equals to true. So that computation for the transformer becomes easy, seemingly easy. Okay, because transformer needs some has some criteria. You have to have this input sequences into sequence of 512 each and every case. If you don't have the sequence, you better pad it with empty spaces, or else don't leave it just like that. So this is what I have done it here. Now, once you have tokenized it, now let's do the pipeline here. Now, for pipeline, that pipeline is going to be a final model, because that's where I'm going to put everything. Okay, so I'll mention it question answer, ANSWER, question answer model here, and I'm going to put pipeline. Okay, thing, and let's understand. I want question answer model. I'm going to say question AN model. The very next parameter will go your model. Okay, which is your model? My model is nothing but the model itself. That's how I named it, right? On the top, if you see, our model name is model. Given. And the very next thing is tokenizer. So if you see my tokenizer also, I named it as tokenizer on the top here. Okay. All this in the pipeline, so that in the pipeline, everything will flow at one go. And the very next thing I'm saying, return me PyTorch tensor. Okay. Return tensors PT, PyTorch. There has no, okay, it's not going to be a from, rather, I think it's going to be a form. Okay, pre-trained. I know I make a lot of typos here. Elongated video, the reason I was typing it a little faster, and that's where things goes wrong. Anyways, yeah, once you have this model done, I mean, I have defined my LLM model, okay, which I've done it first. I should have done my database work first, like the user asking the question. Now I'm going to do that, okay, and I'll build that connection. I'll name it as retriever. What I'm trying to do is, user is trying to make a connection between your the database with the FAISS database. You remember we have push-style embeddings and all over there. Line. Okay, I just I was able to instantiate it properly or not. Yeah, I was able to do it. Now you can see I've used FAISS, HuggingFace. Okay, all these informations are there. Okay, now connection has been established with the retriever. That's how I named it as an object. Okay, DBS retriever. Now I can play around with it. But before I play around, let's define the question. Okay, so I said that I was at that time very naive in asking what is paracetamol. Let's ask some genuine question. Okay, such as what more. Okay, a very nice question, but let's see what it has as a response from there. Okay, now when you have this question, I'm going to have a context, right? So that context, I'm going to put it in context doc. Okay, now here, what I'm going to do is, if you remember this retriever, okay, this retriever is going to retrieve us. Okay, and I'm going to put question. But before I do that, we have a small function to invoke it, and we call it invoke. Okay, retriever dot invoke, and I'll put the question here. How it will look like after this. Remember when we first saw it, right? After we split it up, same thing, but now it has information or context related to only paracetamol. See, paracetamol is not recommended for children. My question is what age group, right? So not recommended for children, so and so. So it find relevant information for me. So it created a context. Now from this context, as I said, I'll pass the question and the context together to LLM, and it will give me a context accurate response. Okay. Now, in order to do that, our context is not in a proper format, right? This context dot is not in a proper format. I'll have to put it in a format so that LLM model can understand. So in order to do that, I'll just name it as context only, and I'll just perform a simple thing. Okay. I'll use a list, comprehension list for talk in context doc. Okay. Right. Already that which part of the talk that I'm going to pick up, I'm going to pick up this page content part. Okay. Page content. I need another thing. If you have already played with the text, you know what this is going to do. Join statement. It's going to club up all the ones together. Okay. And let's see what the context will look like then if everything goes well. Okay. My join spelling is again wrong. Button read up. Now I have all the context put in a proper format. Now once this is done, I have the question and I have the context also in a proper format. I need to pass it. Where am I going to pass this? I'm going to pass this to question answerer model, right? That's the pipeline I'm going to I have. So if I use this and invoke it, it is follow the pipeline and give me the answer. Okay. So I'm just going to put this and I'm going to put the bracket and I'm going to say the question. What is the question that I have? Question I have is the question itself. This is the question, right? I can put it, but I'll rather put this question object. Okay. Equal to what? Age. That's the thing it is going to have. Okay. And what's my question? Context. Context is nothing but my context only. That's how we defined it right here. This is carrying the entire context. So I'll name it as context. Okay. And it just as this. Let's see what's the response that I'm going to get. So it gives me score, start and end, and answer as an adult. This is what I'm looking at. So what age group can have a paracetamol? Only adults. See, short and very crisp answer. It will give me an accurate answer. Okay. That's why when you have a context, it could be a lot of these things. Okay, more than that. Now, when you use LLM, this sort of answer that you get. But when I want this kind of an answer, I would only want adults, right? So how do I get it? Let me put this somewhere. Let me call it as answer only. because it's in a sort of a dictionary format, all that you have to do is put a square bracket and put adults, answer. You liked it, you enjoy it. Yeah. Thank you very much for staying and hope it helped you. Thank you very much, everyone.